So last time we have discussed about the motion on the inside of a smooth vertical circle, and we had obtained the formula above, okay, where v is the velocity at any point, u is the initial velocity at the bottommost part, g is the acceleration due to gravity, theta is the angle. Just to make things clear and just to remind you, okay, u is the velocity at this point, v is the velocity at any point, so where the angle measured from the bottommost point is theta. Okay, so the velocity over here at this point is v, and theta is the angle as measured from the vertical line from the lowest point. Okay, so and capital R that you see in the formula above, it is the reaction. So over here what we were discussing is when the particle was moving inside of a circle. Okay, just like I had given you an example where you have a motorcyclist. He is doing some stunts and he is going around the circle. Let me just mention again, this normal reaction, it is what keeps the motorcyclist do not fall to the side. Okay, if there is no reaction from this surface, the motorcyclist will go to this side when he walks. Okay, just like when he is walking in air. Okay, maybe he is jumping from over here, there is no longer any reaction, so that's why he fall down. But as long as there is a reaction, he will continue to move. Okay, so the normal reaction is what keeps the things in place, okay, attached to the surface. That is the normal reaction. Another motion when discussing about vertical circle, let me just give you an example, is when you are tying a stone. Okay, you tie a stone. Okay, you tie this stone to this rope. Okay, and then you swing it round and round. Okay, but you don't swing it horizontally. You don't swing it horizontally like this. You swing it vertically. Okay, if you swing it vertically like this, then it is also motion on the inside of a smooth vertical circle. Over here, the formula will remain the same, except that for instead of R, instead of the normal reaction R, we are having the tension of the string. Okay, so the tension of the string keeps the stone here. Okay, if there is no tension in the string at all, then the stone will fall down. Okay, but because there is tension supplied by the string, then then it keeps the stone in place. Okay, otherwise the stone will fall down. Okay, so instead of R, you may have D. Okay, but the formula remains the same. Okay, so now that we have discussed that, let us just take a look at the exercises that we will be solving today. Okay, so the two questions, if you see, it is related to what I had just said. Okay, when the particle is tied to a string. Okay, so just take a look at question number 1. You are having a particle of weight W attached to a fixed point by a light inextensible string. Okay, we are mentioning the word light. We are mentioning the word light so that, okay, the string won't contribute to the mass. Because if you see the formula above, R equal M, M is just the mass of the particle. Okay, that is why we are putting the word light, so that the string won't contribute towards the mass. Okay, again, it is inextensible. Okay, so it cannot stretch. Describes a circle in vertical plane as if the tension in the string at the highest and lowest point. Okay, then we have to show that n equal m plus 6. Okay, let me just keep the question here. So over here, what is happening? Again, you are tying a stone and you are swinging it vertically. So what is happening? We have that the tension. So the tension at this point, it will be pointing at this side. This is the tension at the lowest point. When you swing it, then the particle will be somewhere here. Then the tension, it will be pointing in this direction. Okay, so towards the center O. So we are given the tension over here T1, and over here this is T2. So because remember that since we are concentrating, since the angle measured above theta is measured from the lowest point, so you must know that the angle at the point A1 it is 0, at the point A is 0, and at the point A dash it is 180. Okay, this angle is 180 degree or pi. Okay, so that is what we need. Okay, so we just need formula number 2. Okay, R. Solution. Let the radius be A. Okay, let the length of the string, okay, because it's not given, is equal to A. Okay, let it be equal to A. We can do it with any number. Okay, so we will need formula number 2. If the tension at any point is given by T, we are using formula number 2, m u square upon A minus 2g plus 3g cos theta. This is at any point. Okay, but since now we want to find at the point A and A dash, because what is given in the question is the tension at the highest and lowest points. Okay, so at A dash, at the highest point, if you see the question, at the highest point tension is equal to mw. Okay, so sorry, okay, I made a mistake over here because we have already used the symbol small m, so that's why I will replace this one by capital M. Okay, where m is the mass. Okay, capital M is the mass. U is the initial velocity as always. Again, I repeat, I will not be using the same symbols because I've already used it. At A dash, T is equal to mw and theta is equal to pi. So substituting in equation 1, we have mw equal m u square upon A minus 2g plus 3g cos pi. The weight is equal to mg, m small g, u square upon A minus 2g. 3g cos pi will give you, cos pi will be cos 180. Cos 180, it is minus 1, so we will give you over here minus 3g. Capital M will get cancelled. So we will be having mg equal u square upon A minus 5g. So this is equation 2. Okay, so this is equation 2. Now let us take a look what happens at the point A. At A, the tension is equal to Nw if you see the question, and theta is equal to 0. So substituting in that equation, we will be having Nw equal capital M u square upon A minus 2g plus 3g cos 0. Again, Nw will be N mg, will give you m u square upon A minus 2g plus 3g. M and m will get cancelled, so we will be having ng equal u square upon A plus g. So this one is equation 2. Okay, so now let us see what do we need to get. If you are taking a look at the question, we have to show that n equal m plus 6. Okay, so we will subtract them. Okay, because if you take m to the left hand side, it will be n minus m, so we will subtract two equations. Okay, so subtracting equation 3 minus equation 2, it will give you n minus m g, u square by a and u square by a will get cancelled, g plus 5g. So we will be getting n minus m equals 6. G and g will get cancelled. 5 plus 1 is 6. So this completes question number 1. Okay, now let us try to do question number 2. Okay, I don't know what happened. Okay, let us try to solve question number 2. Okay, so it is rotated. Okay, there. Okay, so if you take a look at question number 2, again we are having a string. So we are having over here in question number 2, the solution. It says that the length of the string is L. The length of the string is L. So that means that the radius of the circle is L. Radius is L. Radius A is equal to L. Capital L. And we are having that the velocity, initial velocity, it's equal to 2 root GL. Okay, so prove that the cord becomes slack. What does it mean by become slack? It means there is no more tension. Okay, if the tension is still there, then the string will remain straight. Okay, but if there is no more tension, okay, then the string will become slack like this. Okay, it won't become straight anymore. Okay, so the cord will become slack when it has risen to a height 2L by 3 from the fixed point. Okay, so let me explain what is happening here. We have the radius and we have the initial velocity. So you are tying a string to a fixed point. Now this is the stone that you are tying. If you remember what happened, there will no longer be any tension if the particle reach somewhere to this point. Okay, so at this point theta, this string will become slack. Okay, let the string become slack at point Q. Okay, because if you remember that if you are swinging a particle like this, if you swing it forcefully enough, that is with a very large velocity, then the string will never become slack. Okay, but what happens is sometimes, okay, you may give it a very small velocity, so it will happen to be like this. Okay, so the particle, okay, here there's still tension, but at some point of time there is no more tension. Okay, then and the stone will fall down. Okay, so that is what is happening. Just imagine that you are swinging a stone, okay, and at some point it will fall down. So that is when the string becomes slack. Okay, so let it be at point Q. What we need to find here, this is theta. What we need to find is the height of the point Q from this fixed point. Okay, so we need to find this height y. Okay, we need to find that height y. Okay, let this angle be theta. Okay, this smaller angle be let it be alpha. Okay, you will see why. Okay, when the string becomes slack, then what will happen? Then T will be equal to 0. There is no longer any tension. So by using the formula above, again we will be having m u square upon a minus 2g plus 3g cos theta, it will be equal to 0. m, okay, you can divide it. U square, it will be 4gl. Instead of a will be equal to L minus 2g plus 3g cos theta equal to 0. So this is what is happening. What we are actually doing here is we are finding this angle theta. At which point will it become slack? So over here L and L will get cancelled. 4g minus 2g will give you 2g plus 3g cos theta equal to 0. So cos theta will be equal to minus 2 upon 3. Okay, now alpha. Okay, so the length of the string is L. Okay, alpha. Alpha, it will be theta minus L. Now, alpha equal theta minus theta minus 90 degree. Okay, theta minus this angle 90 degree, it will be alpha, because here it will be 90, so theta minus 90 degree will give you alpha. Why exactly are we finding alpha? Because we want to find y. Now just take a look how sine alpha. Now sine alpha, it will be y by L, because we need to find y. Okay, that is why we are doing all of this. Where y, okay, y is the height above the fixed point, O. Okay, so sine alpha will give you sine theta minus pi by 2 equal y upon L. We can use the formula over here, sine A minus B will give you sine theta cos pi by 2 minus sine theta cos pi by 2. Sorry, minus cos theta sine pi by 2. So sine theta cos pi by 2 will give you 0. So we'll be having 0. Cos theta, we can use equation 1. Equation 1 will give you minus 2 by 3. Sine pi by 2, it is equal to 1. So it's equal to y upon L. So on simplifying, we will be getting y equal to L upon 3. Okay, so this is what we want to get. Okay, just let us see. Yes. Okay, so the height will be 2L upon 3. Okay, so this is again a very easy question. Until next time.